Hello, am I audible?
Yes, sir.
Okay, do you have any doubt from last class?
No, sir.
Just 1 minute. Okay, let me remind you about the last class. We had defined two property. First is elasticity, the tendency of a solid by which it will have tendency to regain its original shape. And the second is plasticity, the inability of a body so that they can't regain their own state on removal of deforming force. On the basis of these two terms, we had defined first stress. Suppose you have a solid body and a force applied on it to deform its shape. So the amount of deforming force applied on body per unit area is termed as stress. Due to this application of deforming force, object would slightly elongated by delta L from its original length L. So we can define another term that is called strain, which is a ratio of amount of deformation produced in a solid and its original configuration. In this part, the deformation is delta L and its original configuration is L. So ratio of these two terms will be termed as strain. Okay. Now, there's relation between this stress and strain, which is defined by Hooke's law. It states the more you apply stress to a particular object, it will develop more amount of strain in it. It means amount of strain developed or produced in a particular object will be directly proportional to amount of stress applied on it. But it will be at some given condition. So according to Hooke's law, at constant temperature, and within elastic limit. I will define you what we mean by elastic limit. Amount of strain developed in a particular object is directly proportional to stress applied on it. So the amount of strain developed in a body is directly proportional to the applied stress. It means stress is directly proportional to a strain. So if you replace this proportionality sign by any constant term, so it will be stress equals to E times strain, where E is proportionality constant and which is also called modulus of elasticity. So from this, we can say stress is directly proportional to a strain. So if you draw a curve related to stress and strain, since these two are directly proportional, so you'll get straight line. And if you rearrange this particular equation, you will get E equals to stress divided by strain. So modulus of plasticity is ratio of stress applied to a particular object divided by strain produced in that particular object. So it will be perpendicular over base, which is equals to slope related to a stress strain curve. So from this, we can say it is equals to slope of stress strain curve or graph. Is it clear till this part?
Yes, sir.
Minashi?
Yes, sir, clear.
Okay. Just write it down. Lakshya? Any doubt?
No, sir.
Okay.
Sir,
Yes.
can you read the first line, like after and?
At constant temperature and within elastic limit.
Okay, so thank you.
You all have written? Khalid?
Yes, sir.
You have written?
Yes, sir.
Okay. Let me give you a question. Suppose you have two substances, A and B, which are inclined at 45 degree and 60 degree. So find the ratio of modulus of elasticity for A and B. Try to solve. Just see how to approach this problem. Since modulus of elasticity E is equals to slope of stress strain curve, and for slope we define tan theta. So you'll say slope of first A equals to tan 60 degree. So it will be √3. And modulus of elasticity of B, it will be tan 45 degree, and tan 45 is 1. Now divide these two terms to take its ratio. So EA divided by EB equals to √3:1. Is it clear?
Yes, sir.
Nabila?
Yes, sir.
Okay. You all have written?
Yes, sir, done.
Okay. Now, on the basis of these terms, we may define its type. Let's say if a solid hang by any support, another so you may apply deforming force to this particular object along this direction or along this direction. So in first case, since deforming force is applied along downward direction to elongate its length, so it will be termed as longitudinal or tensile. In second part, deforming force is applied in upward direction, so it will compress this particular rod slightly, so it will be termed as compressile. Now, due to this deforming force, F, initially rod is of length L. Due to this deforming force, it will get slightly extend to this point. So this will be deformation, delta L, and this part, deformation will be delta L. So first we define stress for either of longitudinal or tensile or compressile. It will be same. There will be change in only in direction of their action. So longitudinal stress, tensile stress or compressile stress is equals to amount of deforming force acting per unit area. Now, due to this deformation or due to this application of stress, amount of deformation produced will be longitudinal strain, which is equals to delta L divided by L. Now, according to Hooke's law, if we divide these two terms, it will define modulus of elasticity. In this longitudinal part, this modulus of elasticity is termed as Young's modulus. So Young's modulus equals to longitudinal stress divided by longitudinal strain. If you put all the values of this, you'll get y equals to F into L divided by A into delta L. Now, this modulus of elasticity or Young's modulus mainly depends upon two factors. First is nature of material and second is temperature. It will be independent of dimension of body and it defines the elastic behavior of that particular object. So here in Young's modulus, as you see, it is defining along its length. So you'll say Young's modulus defines you elasticity of a body along length. Is it clear?
Yes, sir.
Okay, just write it down. Meenakshi, you have written?
Yes, sir.
Now from this we can write first about modulus of elasticity. It defines the elastic behavior of body. Greater the value of modulus of elasticity, it will define more elastic behavior of that particular object. Next, it depends upon nature of material and temperature, and it will be independent of dimension. Now there will be a question, how will modulus of elasticity related with temperature? So you'll say, if you increase the temperature of a particular solid or any object, bond will get weakened, due to which it will slightly lose their ability to regain its original shape. So modulus of elasticity decreases with rise in temperature. It decreases with a rise in temperature. Is it clear? And this will be applicable for all type of modulus of elasticity, whether it will be Young's modulus, shear modulus, bulk modulus. Okay. Raza, is it clear? Okay. Now the second type of this stress is shear or tangential. Suppose you have a cylindrical object whose base is fixed. And if you apply tangential force on its top surface, so it will bend along this path slightly to this. So deforming force applied will be tangential to it, due to which its surface gets shifted by x, or let's say some angle theta. Length of the cylinder is L. So from this we can define first shear or tangential stress. So it will be amount of tangential force applied on this particular object per unit area. Correspondingly, the deformation produced in this cylindrical object is shear strain. So it will be just theta, which is equals to length of arc divided by radius, according to the concept of radian measurement. Now, if you divide these two terms to get the modulus of elasticity in this, it will be defined as shear modulus, which should be equals to shear stress divided by shear strain. shear modulus is denoted by capital G equals to shear stresses, tangential force applied per unit area, divided by shear strain is theta. If you put the values of all term and rearrange it, you will get F times L divided by A times X. So this will be formula for shear modulus. Since in this part, for the application of this tangential force, this shape of this cylinder is slightly deformed, due to which this shear modulus is also defined as or termed as elasticity in shape. Is it clear?
Can you explain the starting part, the shear stress and shear strain?
Okay. Suppose you have a cylindrical object and you applied a tangential force on its top surface, keeping its base to be fixed. Due to application of this tangential force, this cylinder slightly deformed from its top end, keeping its base to be fixed. Okay, Khalid. Then, due to this application of force, this side gets slightly displaced by X amount, or you will say there will be bending of angle by theta. So
Yes.
from this, we can relate shear stress is amount of deforming force, and it should be tangential to that particular surface, divided by area of contact. Next, shear strain is the angle which is equals to perpendicular over base if theta is very small, or you'll say it will be equals to length of arc divided by its radius. So theta is equals to x by L. Now, if you divide these two terms, you'll get shear modulus. So it will be ratio of shear stress and shear strain. Is it clear?
Yes, sir.
Okay, just write it down.
Sir, what is the area of contact here? Area of contact.
This will be
Okay.
on which force acting.
Okay.
You all have written?
Just a second.
Meenakshi, do you have any doubt?
No, sir.
Lakshya?
No, sir.
Done.
Lakshya, you have written?
Yes, sir.
Okay. Now let me give you a problem related to this. A force of 20 kilonewton is applied on a wire having length 2 meters, area of cross section 4 mm square, hanging by any rigid support. Find first amount of stress, amount of strain if Young's modulus is 2 into 10 raised to power 11 Newton per meter squared. And third is elongation, that is delta L. Let me define you how to approach this problem. So in this part, we have some given term. First is force, or let's say this will be deforming force. So F is equals to 20 kilonewton. So first, try to write each given quantity in terms of its SI unit. So we can write it as 20 kilo is 10 raised to power 3 Newton. Or you may write it as 2 into 10 raised to power 4 Newton. Next is length of wire is 2 meter and area of cross section is 4 mm square. So we have to convert this area from mm to meter square. So just multiply it by 10 to the power minus 6 to convert it in terms of meter square. Next is Young's modulus, which is equals to 2 into 10 raised to power 11 Newton per meter square. These are given quantity from this question. Now we have to apply the above formula for longitudinal part and then try to find stress, strain, and elongation produced. Is it clear?
Yes, sir.
Minashi, any doubt?
No, sir.
Suppose if you have to find stress, it will be deforming force per unit area. For strain, we had two different formula. First one is strain equals to delta L divided by L. But in the given question, we don't have delta L. So we can relate it from some other formula. As we had y equals to Young's modulus equals to stress divided by strain. So from this, you will be able to calculate strain as y is given and stress, you will calculate the first part. Try to solve using these formula. We have force equals to 2 into 10 to the power 4 divided by area of cross section 4 into 10 to the power minus 6. So if you divide 4 and 2, you will get 0.5 into 10 to the power 10 to the power minus 6. On moving to numerator, it will become plus 6, and added with 4, it will be 10 to the power 10 Newton per meter square. Or you may write it as 5 into 10 to the power 9. Is it clear, Minashi?
Yes, sir.
Now, using this third equation, as we have value for Young's modulus, which is 2 into 10 to the power 11 equals to a stress we have calculated 5 into 10 to the power 9 divided by strain. So if you move strain to left hand side and 2 into 10 to the power 11 to right hand side, you will get strain equals to 5 into 10 to the power 9 divided by 2 into 10 to the power 11. So on dividing 5 by 2, you will get 2.5 into 10 to the power 9, and here you have 10 to the power 11. So on moving to numerator, it will become minus 11. So 9 minus 11, it will be minus 2. And as strain is a unitless quantity, so it will be as it is. Is it clear? Mazia?
Yes, sir. Clear.
Okay. Now, if you put all the values in the second part, strain is 2.5 into 10 to the power minus 2. Delta L you have to calculate, divide by L, which is of 2 meter. So move this 2 to left hand side, you'll get 2.5 into 2 into 10 to the power minus 2 is equals to delta L. So 2.5 into 2, it will be 5 into 10 to the power minus 2 equals to delta L. It will be in terms of meter. So if you convert it in terms of centimeter, it will be just 5 centimeters. Ehtisham, is it clear?
Yes, sir.
Okay, just write it down.
So actually, I elaborate Young's modulus formula. Y equals FL by ADL. Something
Okay,
like
okay,
that.
okay.
So in red, what did you write after L is equal to 2 meter, comma?
A is equals to
Oh, okay, sir.
you have written this question, Nabila?
Yes, sir.
I have written the values from this question. Raza, you have completed? Okay. A cube of side 10 centimeter whose one face is kept fixed, then a force of 4 kilonewton is applied on its top tangentially. Find first shear stress, second shear strain if shear modulus is 2 into 10 raised power 8 Newton per meter square. Try to solve. Suppose you have a cube like this, whose base is kept fixed, and a force tangential to its top surface is applied, due to which it gets slightly deformed like this. Is it clear to all of you? Or do you have any doubt in this question?
Yes, sir.
Mazia?
No, sir. Clear.
Okay. Area of this particular surface or top surface of cube, which behaves like square, will be side square. So you may use L square where length is 10 centimeter. So 10 divided by 100, 10 divided by 100. So it will be 10 to minus 2 meters squared. Force is given. Just divide these two terms to get shear stress. Good, Sham. Good, Raza. Use the second formula. Shear modulus equals to shear stress by shear strain. And then try to find the value of shear strain. Mirashi, just check your calculation. Put the value of force. Nabila, just check your calculation. Force is 4 into 10 to the power 3, since it is given in terms of kilonewton. So you may write it as 4 into 10 to the power 3 Newton. Divide by area, which is 10 to the power minus 2. So if you move this denominator to numerator, its exponential will become positive. And we have already 10 to the power plus 3. So 10 to the power plus 3, 10 to the power plus 2, it will be 10 to the power plus 5. So 4 into 10 to the power 5 Newton per meter squared. So this will be your amount of shear stress due to this.
Okay, sir.
Now, from this second equation, if you move shear strain to left hand side and shear modulus to right side, you will get shear strain or theta equals to shear stress divided by shear modulus. The value of shear stress we have calculated as 4 into 10 to the power 5, and the value for shear modulus is given in the question as 2 into 10 to the power 8. So 2 into 2, it will be 4. And if we move 10 to the power 8 to numerator, it will become 10 to the power minus 8. You have already 10 to the power plus 5. So plus 5 minus 8, it will be 10 to the power minus 3. So you will get 2 into 10 to the power minus 3 as shear strain. And since it is unitless quantity, so there will be no unit. Raza, is it clear?
Yes, sir.
Minashi, any doubt?
No, sir.
Okay. You all have written?
Yes, sir, done.
Valid? Now let's start the third part of this. Which is called volumetric or cubical. Suppose you have any sphere on which force is applied from all its sides. Due to application of these forces, it will get slightly shrink to this. So in this part, there will be change in volume, as these forces will be perpendicular to the point of contact or tangent. So if a force is perpendicular to point of action, that will be termed as pressure. So we can say volumetric stress, which should be force perpendicular divided by area, and it will be change in pressure or simply pressure applied to that particular solid. The corresponding change will be termed as volumetric strain. So it will be equals to change in volume divided by volume. Since initial volume of sphere is larger as compared to its final, so change will be in negative. So volumetric strain will be in negative. Now, if you divide these two terms, you will get modulus of elasticity. In terms of volumetric, it is termed as bulk modulus. So it should be volumetric stress divided by volumetric strain. So bulk modulus is denoted by beta equals to volumetric stress, that is pressure or change in pressure, divided by volumetric strain, that is delta V divided by V with negative sign. So you may write it as minus of pressure into volume divided by delta V. Is it clear?
Sir, why didn't write delta P, sir?
You may use delta P or simply P. Now, this bulk modulus defines you compressibility or rigidity of that particular object. So it will be termed as compressibility. Okay, just write it down. You all have written?
Yes, sir.
Minashi?
Yes, sir.
Okay. Now there will be question to find a relation in terms of radius of this particular solid sphere. So as you know, volume of a sphere equals to 4 by 3 pi r cube. 4, 3, pi, these all are constant term. So according to the rule of exponential error, which I had defined in the second chapter, that is in units and dimension, if you relate to find fractional change in volume, so it will be delta V divided by V. These constant terms will be neglected in terms of dimension. And here we have r raised to the power 3. So using the concept of exponential, it will be 3 times delta r divided by r. It means the exponential will move to the coefficient of that particular part. Is it clear?
So can you repeat again, sir?
Where we have p equals to x to the power m, y to the power n. So if you have to define fractional change in p in terms of x and y, so according to the rule of exponential, it will be delta p divided by p equals to this exponential of x will move to its coefficient. So it will be m times delta x divided by x plus y raised to the power n. It will be n times delta y divided by y. Is it clear?
Yes, sir.
Similarly, I have used this. In this part, we have volume and r cube, only these two terms. So delta v by v, which having only one as exponential. So you may write it as 1 times delta v by v, or you may left it 1. 4 pi and 3 is constant, so neglect it. R having exponential 3, so it will move to its coefficient 3 times delta r by r. Is it clear? Nabila, is it clear?
Yes, sir.
Now, if you put this value in the above equation, since volume is decreasing, so here we'll have negative sign. Similarly, in radius will be also negative sign. So beta will be equals to change in pressure or simply pressure divide by delta V by V, which is equals to 3 times delta R by R. So this minus and this minus will cancel out. And since you have to find delta R by R, so move it to left side, you will get delta R divided by R equals to pressure divided by 3 times beta. So this will be your expression of fractional change in its radius. Mazia, is it clear?
Yes, sir.
Done, sir.
You all have written?
Yes, sir.
Fine. Amount of pressure must be applied on a cube to change its volume by 1% if beta is 4 into 10 raised to power 6 Newton per meter squared. Let me define you how to approach this type of problem. So in this part, you have percentage change in volume is 1%. So you may write it as delta V divided by V into 100. So this will be a percentage change in volume, which is equals to 1. But in the formula of bulk modulus, we have to use only delta V by V. So just move this 100 to the other side. So you will get delta V divided by V is equals to 1 by 100. So this is your first value. Next is bulk modulus of substance is given. Beta is equals to 4 into 10 raised to power 6 Newton per meter square. Now use the formula beta equals to pressure or change in pressure divided by delta V by V. Since volume is decreasing, so there will be negative sign here, or you may write it in here. Just simplify it to find the value of pressure. Ehtisham, just check your calculation.
Okay, sir.
So you may write pressure is equals to beta times delta V by V with negative sign. Put the value of beta and delta V by V and simplify it. Raza, negative sign will cancel out. We have beta as 4 into 10 raised power 6 and dV by dy as minus 1 divided by 100. Good, Nabila. So this minus and this minus will cancel out. You have 10 raised power 6 in numerator. You may write 100 as 10 raised power 2, which is in denominator. So if you move this term to numerator, we 10 raised power minus 2. So on simplifying it, you'll get 4 into 10 raised power 4 Pascal or Newton per meter square. Minashi, is it clear?
Yes, sir. Clear.
You all have written?
Just a second.
Okay.
Done, sir.
Muhammad Khalid, you have written?
Yes, sir.
Okay. Now to define the next problem, let me define you about concept of tension. Nabila, do you have any idea about tension?
No, sir.
Okay. Suppose there is support from which rope, wire, or string is hanged freely like this. So due to its slackness, you will say there will be no tension in it. Now, if you attach a block at its end, so this string or rope will get straightened due to application or due to action of gravity on this particular block in downward direction. So it will be mg. So you will say a force which develop in a string, wire, or rope due to its straightness on application of any force is termed as tension. So tension is the force which develop in a body and wire, string, or rope due to its straightness. Is called tension. Next is for massless string, tension will be same at each point. So next is for massless, inextensible string, rope, tension will be remains same at each point. Next is it always acts opposite to the point of contact. It acts opposite to the point of contact. So in the second example, since point of contact for this particular string is at this point at lowest end and at this point at its top end. So tension will be opposite to the point of contact. So it will be in this direction at this point, and at this point it will be in this direction. Is it clear?
Yes, sir.
Now, if you see this whole part, since there is no acceleration of this particular block, it means net force acting on this particular block will be 0, which means total upward force should be equals to total downward force. So tension equals to mg. Raza, is it clear?
Yes, sir.
Now in this part, or for calculation of modulus of elasticity stress strain, this tension will be responsible for deformation of object or deformation in the wire. So it will be termed as deforming force. So first write it down, then I'll give you some problem related to this. You all have written?
Yes, sir.
Yes, sir, done.
Mohammed Khalid?
Yes, sir.
Okay. Suppose you have support like this, from which string, another string is connected. Mass of this string is 2 kg, or this block is 2 kg, and mass of this block is 3 kg. So find ratio of stress if wires are identical. So let me define you how to calculate it. First, try to draw tension for the lower segment. As mass of block is 2 kg, so it will be attracted by gravity in downward direction. So it will be 2 times gravity, or 2 into 10, 20 Newton. Tension will be opposite to the point of contact, so it will be in this direction, T1. So from this we can say T1 equals to 2 times gravity. Is it clear? Minashi?
Yes, sir.
Yes, sir, clear.
Okay. Similarly, you may draw at its top point, tension will be T1. Now, for second block, as its mass is 3 kg, so there will be a force in downward direction, mass times gravity. And at this point of contact, tension will be T2, since strings are different. So if you calculate T2 from this part, so total upward force should be equals to total downward force. So it will be T1 plus 3 times gravity. The value of T1 is 2 times gravity. So 2 plus 3, it will be 5 times gravity. Nabila, is it clear?
Yes, sir.
Now, since wires are identical, which means area of cross section of first and area of cross section of second will be equal. Now apply the formula for a stress and take the ratio. Try to solve. Let's say this is your wire first and this is your wire second. As stress is equals to 4 divided by area, so stress in first wire divided by stress in second wire will be equals to force in first divided by area in first, and denominator of this will reverse, so it will be area of second divided by force in second. Okay, Khalid.
Thank you, sir.
So force divided by area divided by force divided by area. If you rearrange it, you will get F1 over F2 into A2 over A1. As area of cross section is same, so this and this will cancel out. T1 is equals to F1 and T2 is equals to F2. Just put these values. So F1 will be equals to T1, that is 2 times gravity, and F2 is equals to T2, that is 5 times of gravity. Gravity gets cancelled out, so ratio will be 2:5. Is it clear?
Yes, sir.
Yes, sir. Done, sir.
Minashi, any doubt?
No, sir. Clear.
Okay. You all have written?
Yes, sir.
Okay. Now from this, just remember, for perfectly rigid body, there will be no deformation in length or in volume. So modulus of elasticity, that is Young's modulus, shear modulus, and bulk modulus will be equals to infinity. So you may be asked to define the value of modulus of elasticity for perfectly rigid body. So you'll say in perfectly rigid body, there will be no deformation. So delta L, delta V will be 0. So if you apply the formula, Young's modulus equals to force into length divided by area into delta L. So if there is no deformation, so delta L will be 0. And 1 divided by 0 will be nothing but infinity. So modulus of elasticity will be equals to infinite. Is it clear?
Yes, sir.
Yes, sir.
So do you have any doubt till this part? Nabila?
No doubt, sir.
Okay. Now the next important part of this chapter is stress strain curve. In vertical direction, a stress or longitudinal stress correspondingly amount of strain developed or produced in the body. Suppose a rod is hanged and load is being applied, which keep on increasing. And we have to define certain behavior of this particular object related to its expansion. First, it will move from this point to this point like this. Now at this point, if you remove deforming force, it will return back to its original point, that is at this point. So from O to A is termed as elastic limit. So elastic limit means the limit up to which it has tendency to regain its original shape. Is it clear? Suppose a rigid body which is hanged from any support and a deforming force is applied to stretch it. So if you stretch it up to point A, and if you remove the deforming force, the body will have tendency to regain its original shape exactly. So up to A point, it will be termed as elastic limit. Is it clear?
Yes, sir.
Now, if you further stretch it till this point B, object will have still the property of elasticity, but it would have lost some amount of elastic behavior, due to which it will get slightly deformed. And now if you remove deforming force, it will reach up to this point, having some deformation with it. And this deformation, which is permanently stored in it, will be termed as permanent set. And it will be almost 1 to 2% of its actual length. Is it clear?
Yes.
So you will say up to point B, object having elastic behavior or elasticity, but Hooke's law will be applicable only to point A. So this B point is also termed as yield point. Now, if you further stretch this wire from B, so it will move along this. And for this path, it would have lost the ability of regaining its original shape, that is elasticity. So during B to C, there will be no elastic behavior of object. So now the behavior of object is termed as plastic. So this region from B to C is termed as plastic region. Is it clear?
Yes, sir.
So C is the maximum value of stress a body can withhold without breaking. So C is termed as ultimate stress, or the maximum stress withheld by any object without breaking. Now, if you apply further deforming force to this body, now it will start flowing, and at any point D, it will get broken. So point D is called breaking point or fracture point. From C to D, it will have tendency to flow like jelly. Is it clear?
Yes, sir.
Sir.
So from this graph, you will have to explain each term or point. So let me define you. From O to A, if deforming force is removed, object will acquire its original shape exactly. So up to this point, Hooke's law will be valid. Next is from A to B, object will have still elasticity, but with some permanent deformation. Next, from B to C, object will lose their ability of regaining. So now object will have plastic behavior. And point C is termed as maximum stress, and point D is termed as breaking point. Is it clear to all of you, or do you have any doubt?
Clear, sir.
Nabila?
No doubt, sir.
Okay. Okay, just write it down. Since I had defined or draw the graph for longitudinal or elongated part of only, similarly, there will be a curve for its compression as well. So it will be along this. Similarly, O to A, then it will move to point B, then it will further stretch to point C, and then it will tend to flow and fractured at point D. So this will be termed as compressile stress. So you'll be asked only for the longitudinal part.
So in compressor stress, the object won't break, right?
It will be deformed into thin sheets.
Ah, okay.
So it will get fractured at different point after ultimate stress.
Done, sir.
Done, sir.
Minashi, you have written?
Yes, sir.
Mazia?
Sir,
Okay. So let's stop here. I will define you some term related to this particular graph, and I have left one portion, one topic, that is potential energy stored in a wire, which is the last topic of this chapter. And then we'll start mechanical properties of fluid. Okay?
Yes.
Okay then.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you.
Thank you.